सपने सजाए फ्यूचर के लगा जकरबर्ग को देंगे मात। जब आई असली कोडिंग की बारी तब क्या लगा हाथ। चुनो कोडिंग निंजास। इन्होंने बनाए हैं 50,000 से ज्यादा प्रो कोडर्स प्लेस्ड इन लीडिंग टेक कंपनीज। कोडिंग में करियर मतलब कोडिंग निंजास।
Hi everyone, welcome to the second day of the workshop. Uh, Previous day we discussed just the basics of IoT, which didn't had internet. Today we will embed internet on those sensors and send the data to cloud. And in the cloud we will either make decisions or we will visualize the graphs. Next one. Today we will learn about relays, electronic switch. What is ESP8266? Uh, a Node Mcu microcontroller based upon ESP8266. Some cloud platforms like Adafruit and ThinkSpeak. Sending data to those cloud platforms, visualizing them and making decisions. IFTTT, a third-party platform which connects two different platforms. And the last will be working with Google Assistant and making the appliances automatic. What is ESP8266? ESP8266 is a low cost Wi-Fi microchip which consumes very low power. It has built-in TCP and IP networking software. This is something related to communication in networking. ESP8266 has 2.4 gigahertz Wi-Fi. It doesn't support 5 gigahertz. It has general output and input pin, which we discussed as digital and analog yesterday. Some I2C pins for communication, analog to digital conversion, and some SPI pins. Node MCU. Node MCU is a development board which is based upon the ESP8266 microchip. That means, in simpler words, it is Arduino, but it has the capability of, in simpler words, it can do any network which you have access to. What is relays? Relays can be simply defined as electronic switch, the normal switch we use to switch on or off any electrical appliance. It is same, but it doesn't need any human interaction to switch on or off. We will use it on our projects. Uh, what is MQTT? Just you need to get a brief overview on this. What is MQTT? MQTT is messaging, queuing, telemetry, transport. It is a standard messaging protocol for Internet of Things. Uh, messaging messaging protocol means it has the ability to either send or receive messages for IoT, and it is extremely lightweight. Like in very low bandwidth, also it can work very efficiently. We'll start with the today's cloud platform. The first one we'll see today is Adafruit. I request everyone to open this website. First, you will see something like this. Internet. Hmm? Once you create your account, please say, I'll give it a minute or two. After you sign in, you will see something like this without any dashboards. I'll start explaining a few things. What is profile? Profile is where you can see what is the current usage and how many data are flowing per minute, or what is the usage for free account and things. What is feed? Feeds are something like a panel where all your dashboards are collected. What is dashboard? Dashboards are a window where you can see or interact with your data that you have sent with your development board. Uh, and the last one is my key. This is the secret key which you need to note down when you make a dashboard. This key is used to send the data to a particular dashboard. Once you land on this page, create a new dashboard, name it anything like workshop. Click on the name, edit the dashboard. You'll see a window where no widgets are there. Click on the settings button, edit layout. Sorry. Create a new block, and you can see different types of blocks which you can use. This one is for toggle switch, just like on or off. This is slider buttons, continuous data. Uh, Here you can see gauge and line chart, and many different things are there. We'll see first the toggle button. It is asking to connect to a feed. Which feed do you want to connect? Any feed you can write, like test. Next step. What is the block title? You can write anything. Switch. When the button is on, what do you want here to be written, and what do you want to be written when it's off? We'll leave these values as default, and we'll create the block. Uh, After this, we will see another platform called ThinkSpeak. ThinkSpeak is mainly used for visualizing data. It is good when it comes to make a graph or visualize them. It is based upon the MATLAB. You can make account and land on this page. Actually, you will land here with no channels. These boxes will be not present in your window. After that, you can make a new channel, just like same how we did in Adafruit. After we make a new channel, we will see private view, public view, channel settings, sharing, and API keys. Uh, API keys are something which you will feed in your program for reading or writing the data to this particular channel. It goes same with Adafruit. This my key is nothing but API keys, which is used to monitor data, read or write, like what is the change if I click this is switched on. So how will I know that this button is switched on? My key, this API key will help me to know what is happening. Once you create ThinkSpeak and uh, once you create account in Adafruit and ThinkSpeak, we'll start for the Node MCU part in hands-on. Okay, we'll wait for 5 minutes. I request everyone to make account in your Adafruit, io.adafruit.com and thinkspeak.com. Now we'll start discussion upon Node MCU. तो Node MCU है क्या? Node MCU एक normal development board है, which is based upon ESP8266. Or this chip is basically the Wi-Fi part, which is embedded in the development board, which helps us to connect to the internet. Uh, we need to first see what is Node MCU. If we open the Wikipedia page, uh, it says that Node MCU runs on ESP8266 Wi-Fi, which we have already seen. There are some things we need to know, that there are two versions of Node MCU available, which is 0.9 and 1.0. We have both in our lab. So when we are making project, like we will do a hands-on now. So please make sure that you select the right one. We will help you with that. And the main thing we need to know is like this GPIO pin thing. In case of Arduino, GPIO stands for General Purpose Input and Output. Like the digital one we were using yesterday. That was used both for input and output. So we say that the pin is GPIO pin, General Purpose Input and Output. In case of Arduino and all forms of Arduino, like Arduino Uno, which we used yesterday, Arduino Nano, Mega, uh, it happened that whatever the pin number was, like pin D1, it had GPIO1. So we wrote in the program pin number 1 is and we plugged in pin 1. But in case of Node MCU, there are some things much different than Arduino. If we are plugging it in pin 1 in Node MCU, in program we need to write its pin 5. If we are plugging it into pin number 2 in Node MCU, in program we will write 4, and so on. You can search it in the internet and see what pins we are plugging it, and in the program what pin number we will write. Please pay attention to this. This is very important thing. If you will miss this part, Node MCU काम नहीं करेगा. Okay, so we'll now see the pin out of pin diagram of Node MCU. As for the Arduino had a 5-volt output. Node MCU doesn't have a 5-volt, it has 3.3 volts output. And see, like it's written D0, but it is GPIO 16. So whenever we write in the program, like we'll write in the program pin number equals to 16, and we will plug it in D0. And there are many pins. There are total 9 digital pins, and it has a disadvantage. It has only one analog pin, A0. Okay, so we will start with the hands-on now with Arduino. Open your Arduino. Like yesterday we discussed, when we are plugging the board, we need to select the board from here, and we selected the board Arduino Uno. For today we are using a totally different board, but in your computers, please pay attention guys, but in your computer when you will go to board, you will not see this ESP8266 board. Please check and confirm. नहीं है, ठीक है. So we will add this package. For adding this package, we will go to the GitHub page of ESP8266. This is the GitHub page for official ESP8266. We will click on Arduino. And when you scroll down, you will see a board manager link, which is a JSON link. It includes all the board managing files for Arduino IDE. Copy it. Open your Arduino. Huh? Oh, ठीक है डाल लेना. Go to preferences, go to files, then preferences. You will see additional board managers URL. Okay, I have already pasted it. You paste it, click OK. Some files will download, let it happen, then we'll start again. After you paste the JSON link here, click on OK. Go to Tools, Board Manager, search for ESP8266. You will see something like this: ESP8266 by ESP8266 community. Okay, uh, and लाइक मेरा इंस्टॉल्ड है, तो यहाँ पे इंस्टॉल बटन डिसेबल्ड है, तुम लोग का इंस्टॉल बटन आ रहा होगा, उस पर क्लिक करो और उसको डाउनलोड होने दो. Okay, guys, please pay attention. हाँ, let it install. We will see how the program works for sending the data to Arduino and receiving the data from sending the data to Adafruit and sending data from Adafruit to Node Mcu. Okay, when if you search in the internet, like there will be many different programs. I have copied a program from net. Okay, uh, we will see what each and every line in this program does. Okay, these are the libraries: Adafruit MQTT, Adafruit MQTT, the library for Adafruit. Adafruit client, it is used for subscribing, like in MQTT there are two terms. One is publish and other is first we will see publish. Think of a magazine company. You are asking to publish your article. That magazine company can be said as MQTT. You are asking MQTT to publish your data into it. Okay, like we are sending the data. And the other one is subscribe. The subscribe is like if we relate to the magazine company, it is the client or the the people who are subscribing a magazine, like if I subscribe a magazine, whenever a new magazine releases, the company will deliver it to me. In case of MQTT, what it happens, whenever a new data is published in the MQTT, the subscribe function sends the data to the program where I have subscribed that particular topic. Okay, that what is this? This sends data from Adafruit or MQTT platform, whatever we are using Adafruit, to the board, whatever you are using. We are using ESP8266. Okay, these two terms you have to keep in mind every time. So coming back to the program, we are importing the libraries, define some user defined variables like server link. These are constant things. Like for Adafruit, we will always use io.adafruit.com. For ThinkSpeak, it will be API ThinkSpeak.com. The server port, it will always be the same. The user key, the username, and the API key, which I was explaining before. When you go to the My Key option, you will see the username and active key, which we will paste in the program. This will help the program to decide where to send the data. Okay. Then we are making a variable called client of data type Wi-Fi client. I'll explain this later. We are connecting to the Adafruit MQTT client by providing the parameters. What are the parameters? The parameters are Wi-Fi client, the server link, this one, the server port 1883, in what username and what API key we have to connect, that. Or else we can directly write this as like this, and instead of IO server, you can paste this one directly without defining it to any variable. Okay, and same for the rest things, but we'll not do here. It makes the program look very neat. uh, Coming back to this function, I'll explain later. What was the feed was the window or the dashboard where we can see our data. So what we will do, we will publish. We are sending the data to the MQTT. So what we will do, when we have to send the data to MQTT, we always publish. So what we will do, Adafruit MQTT publish, and in which server we have to publish, that decides, that we are declaring here, like MQTT. What is this? This is a variable name. You can change it to anything, but this parameters will be same. Then username and your feeds slash tests. What was test? Test was the feed you made before. For this, like this feed is called workshop. So what we will write? We will write here feed slash workshop. Serial begin for connecting the board to the PC. Disconnect the Wi-Fi, wait for 3 seconds. Uh, these statements just make the serial monitor look good. We are printing a start, like we are starting the program. Wi-Fi begin workshop, comma workshop. What is this? This is we are connecting to the Wi-Fi. This function accepts two argument, that is your SSID or the Wi-Fi name. Like if we see here, what is the Wi-Fi I am connected to? IoT lab, and there are certain this is called SSID, and what is the password for that SSID? Okay, so this can be also written as like this, SSID and the password, and we can define these variables SSID, char SSID star is equals to your Wi-Fi name, whatever it is. it might not connect to your KIIT Wi-Fi, so I'll request everyone to like turn on your hotspot and work upon this. After we begin our Wi-Fi, we check if it is connected or not. If it is not connected, we will wait for 300 milliseconds. Just print two dots to make our serial monitor look good. And again, we will try this. This function keeps on trying until our Wi-Fi, until our ESP8266 is connected to the Wi-Fi which we wrote here. Okay. After that, we print connected and whatever the local IP is of the connected Wi-Fi. Void loop, as I discussed yesterday, void loop uh, repeats the inner lines repeatedly. So what it is doing? Uh, if MQTT connect, what is MQTT connect? We are checking if the ESP8266 is connected to MQTT server or not. What was MQTT server? This one, MQTT connect. What this function is doing? We will check if MQTT is connected or not. If it is connected, return true. Else this part will be executed. What is this? This is an unsigned integer of 8 bytes. Uh, you need not to worry about this. You can treat it as normal integer. We are making a user defined variable named retries. You can name it anything. Retry is equal to 3. I have written 3. I'll give it, I'm giving a 3, I'm giving 3 chances or like 3 repetitions before the program ends or the program breaks. You can give it any number, 5, 10, 15, how many chances you want to give the ESP8266 to connect to the Wi-Fi. After that, we run a loop to connect to the MQTT. Like number of retries is equal, RET is equal to MQTT.connect. MQTT.connect returns 0 when it is connected. Okay, I'll write here MQTT.connect returns 0 if connected or else 1. Okay, so if MQTT is connected, it is returning 0. So what is stored in RET variable? 0. If 0 is not equals to 0, this will go false, and we know that MQTT is connected, so this while loop will not work and we will return true and come out of this function. Or if it is not connected, then it will return 1. RET has the value of 1, 1 not equals to 0. This will keep trying until the number of retries, this number of retries gets to 0. If it gets to 0, the program breaks and we have to reset our program or rerun the program. After the MQTT is connected, uh, we publish the data to the feed which we wrote here, uh, dot publish, and we will print in the statement that it is published and else not published. Or if this part is not connected, we will write a statement like MQTT is not connected. Okay, so I guess till now your installation might have been completed. Okay, so I guess ओके सो अब हम लोग आते हैं नोड एमसीयू कनेक्ट करने के पार्ट में। After you connect your node MCU to the cable, open device manager. Open device manager. Go to ports. यहाँ पे सिलिकॉन लैब्स सीपी जो आ रहा है मेरा, ये हो सकता है तुम लोग का ब्रोकन होगा, हो सकता है किसी किसी का ब्रोकन हो सकता है किसी किसी का ना हो। ब्रोकन है ना? ठीक है। Go to your browser, search for the same. Okay, search for what we will search. CP USB to UART bridge controller. If your driver is broken, or in place of this USB symbol, if you are seeing a triangle and an exclamation mark, and go to downloads and download the driver for Windows. Okay, as in offline there is no broken drivers, so we can continue with hands-on. For the online people, if it is broken, please install the driver and continue with the work. After you connect your node to your laptop, open go to files, go to examples, basic, blink. A new window will open which has the same program which we did yesterday for blinking the LED with the interval of 1 second. But as you can see, there is no other pins defined, and it is written here LED built in. Whenever you plug in your Node MCU, you see a small blue light that is built-in LED of Node MCU, or in any board, in Arduino or any other boards of Arduino Mega and Nano, there is a built-in LED. So we will go to tools, go to boards, select the board which we are using, Node MCU 0.9 ESP12 module. Click on that. Open the device manager once again. Go to ports, and you will see the communication port number in which you have plugged in your Node MCU. For my case, it is COM9. So I'll go to tools, go to port and select COM9. Click on upload. It will take a minute or two. And you will see some logs here, like flash size and which board we are using, ESP8266. Okay, and we will write the program is being written to the microcontroller. Click on the serial monitor. Oh, sorry. And if you see your Node MCU, you will see a small light blinking. That is the built-in LED of Node MCU. I hope everyone. Guys, please pay attention. I hope everyone might have done the blink program. किसी का ऐसा कोई है जो नहीं हुआ जिसका तुम लोग का छोड़ के? और कोई? ठीक है. Now we will send data to Adafruit. For that, we have given a GitHub link from where you might have copied the code. The program is for we will send the data to Adafruit. तो कोई बता सकता है कि हम लोग कौन सा प्रोग्राम यूज करेंगे? Adafruit सब्सक्राइब के Adafruit पब्लिश, ठीक है, Adafruit पब्लिश यूज करेंगे. तो ये है Adafruit पब्लिश का कोड. ये वाला कोड have I explained? हाँ, I have explained this code. तो सब अभी क्या करो कि अपना Adafruit अकाउंट खोलो, ठीक है. एक डैशबोर्ड में एक वो बनाओ, फीड में एक नया ब्लॉक बनाओ, ठीक है, और उस ब्लॉक का नाम जो तुम्हारा मन करे वो दो, ठीक है, उससे कोई दिक्कत नहीं है. जो फीड का नाम दोगे, ठीक है, वो नोट कर लेना. जो फीड का नाम दोगे ये जैसे हम वर्कशॉप दिए तो वो वाला नोट करके रखना, ठीक है. जब फीड बन जाएगा तो हम लोग क्या करेंगे कि फीड्स स्लैश कौन सा फीड है हम लोग का? वर्कशॉप. तो यहाँ वर्कशॉप लिखो, ठीक है. उसके बाद अपना अपना हॉटस्पॉट ऑन कर लेना फोन का, SSID और पासवर्ड चेंज कर लेना, ठीक है. इतना करो फिर बताते हैं. For generating a random number in Arduino IDE, we just write random and the starting initial value from where you want to generate the random number. Like I want to generate random number from 0 to 50. Okay, we will take it in a variable. लास्ट दिख रहा है तुम लोगों को? इसको एक वेरिएबल में लो, int रैंडम नंबर, ठीक है. ओके, ये यहाँ नहीं, यहाँ जाएगा, कंट्रोल X, ठीक है. और ये जो रैंडम नंबर है इसको यहाँ पे पब्लिश कर दो. इतना करो फिर बता रहे हैं. अभी कोई रन मत करना प्रोग्राम क्योंकि एरर आएगा. प्लीज मेक दिस चेंजेस इन योर प्रोग्राम, देन वी आर रनिंग आउट ऑफ टाइम गाइस, तो थोड़ा सा फास्ट करेंगे, ठीक है। तो आई होप कि तुम लोग ये चेंजेस कर लिए होगे। क्या क्या चेंजेस करना है? एक तो अपने फोन के हॉटस्पॉट का SSID या फिर जो हम लोग नेम बोलते हैं हॉटस्पॉट का, और उसका जो पासवर्ड है वो हम लोग इसके यहाँ डाल देंगे, ठीक है। उसके बाद फीड स्लैश, ये जो नाम है, ये जो नाम हम तुम लोग खुद से बनाए हो, वो जो फीड का नेम वो यहाँ डालोगे। उसके बाद ये जो फीड का जो वैल्यू या फिर जो भी इसका डेटा है वो एक वेरिएबल में स्टोर कर रहे हैं। ये जो अल्ट्रा लिखे हैं हम, दिस अल्ट्रा इज अ यूजर डिफाइंड, यहाँ पे कुछ भी लिख सकते हो, लाइक यू कैन राइट योर नेम, नेम इज अ कीवर्ड इन Arduino IDE, तो कुछ और लिखो, ठीक है, लाइक नेम अंडरस्कोर कर लो। और वी आर पब्लिशिंग डेटा टू दिस फीड, और ये फीड का डेटा किसके अंदर स्टोर है? नेम अंडरस्कोर के अंदर। तो वी आर इन शॉर्ट पब्लिशिंग डेटा टू नेम अंडरस्कोर। तो व्हाट वी विल राइट हियर? वी विल राइट द वेरिएबल नेम विच वी डिक्लेयर्ड हियर, ओके। सो पहले मेरा क्या लिखा हुआ था? अल्ट्रा। तो व्हाट आई डिड, I want to publish the data in Ultra, so I wrote here ultra dot publish. If there are multiple feeds, if there are multiple feed 1, and whatever the feed name is, we can write uh, feed 1 dot publish, ठीक है। And we are publishing a random number. We generated a random number from 0 to 50. If that data is published, we print data sent, or else data not sent, okay. If you run your program, you might get a error no such module करके. तो how we will import modules? Whatever the module name is, whatever जो तुम्हारा आ रहा है यहाँ पे, no such module, whatever the name is, I guess Adafruit mqtt.h नहीं आ रहा होगा. Copy this, go to Chrome, search for it. Whatever the GitHub link you find, the first link, click on it. Download the zip. Once you download, go to tools. Go to sketch, include add.zip library, click on it. Your local browser will open. Go to the downloads folder where you keep the downloads file. You will find the zip file Adafruit mqtt library.master. Open it. As I have already added the zip library, I won't. You please open this file and run the program once again. Then it might say that ESP8266 Wi-Fi.h is not found. Do same for it. Search for the libraries in the internet. Go to github.com, download the zip file, go to sketch, include library, add zip library, go to downloads where you have downloaded that file, click on that, open. After that, close your Arduino IDE window, every window, like I have 3 windows open here, close every and open it once again and upload the program. After few seconds, the program will get uploaded. Just after it uploads, click on serial monitor. Not while uploading, it might throw an error. Just after the uh, logs say done uploading, click on the serial monitor. It will show that it is taking. Okay. Huh. It connects to the Wi-Fi of the hotspot, my phone hotspot. It shows the IP in which I am connected to, and it is saying that data is sent. Now we need to check if the data is sent truly or not. We will go to the feed, and we will see that the data is being sent. Like now it is 12:44, and I can see that it sent a data 26 value 26 on 12:43:41. If you refresh it, okay, I can see many values here, like 26, 30, some random generated values between 0 to 50, and it will make a graph, and we can see the logs also of every 2-second delay. Like in every 2 second, it is generating a random number and sending it to uh, the MQTT. You can also see the graph here. जो स्विच हम लोग बनाए थे एडाफ्रूट में, गो टू द सेट फर्स्ट, ऐसा कुछ दिख रहा होगा. क्लिक ऑन द सेटिंग्स बटन, एडिट लेआउट, सेटिंग्स वाले ब्लॉक में एक सेटिंग्स आइकन आएगा. क्लिक ऑन द सेटिंग्स, एडिट ब्लॉक. नेक्स्ट स्टेप, they are asking for two values. Button on value, okay, button on value, what it is, a value by which, या फिर इसको ऐसे बोल सकते हैं कि किस वैल्यू पे बटन ऑन होगा एंड दिस इज किस वैल्यू पे मेरा बटन ऑफ होगा. तो जनरली वी यूज 1 फॉर ऑन एंड 0 फॉर ऑफ. ओके, अपडेट द ब्लॉक. Go to the same program which we were running for random numbers. Change the feed if it is needed. For my case, it is workshop. I'll paste workshop. Check for the Wi-Fi connection and switch this. And then we have to save the layout, save it, and switch this on. Okay. Go to the program and if we run this program, remove the random value generation function and in place of ultra.publish, just publish 0. Okay, and make sure the switch is on. After that, click on upload. And guys, please make sure that you are not using my key. So what happened? Ki this switch was connected to the feed named workshop and this switch had the function कि अगर 0 आएगा तो इसको ऑफ हो जाना है, अगर 1 आएगा तो इसको ऑन हो जाना है. ओके, तो what I did, first I switched it on and I send a data 0. तो जब 0 आया तो क्या हो गया, ये ऑफ हो गया. One thing what we can do is after sending publish, we can copy paste this, put a delay of 2 seconds and publish here 1 and upload the program once again. Now you can see with a delay of 2 seconds, this switch is switching on and off in every 2 seconds. I'll remove the cursor. देखो ये खुद हो रहा है, ठीक है? How? We are sending the data 1 and 0 with a delay of 2 seconds. Okay. Now we are sending the data to the Adafruit. Now what if we want to see if the switch is on or off? Then we will use the program Arduino subscribe that is in the GitHub which you are downloaded. Copy the program and paste it in the Arduino IDE. Please make sure that when you are using the subscribe program, first you need to change the username, then the authentication key, your hotspot SSID and password, then the feed name, and rest everything will be same. Open the serial monitor after it's uploaded. Okay. So whenever I switch it on or switch it off, it sends the respective data like 0 for off and 1 for on. Now it is off, so 0. When I'll click it on, got 1. Okay. This is how we read data from the feeds from Adafruit. Now we will use this to turn on relay and turn off relay. What is relay? I already told you that is an electronic switch. Uh, how does relay work? If the voltage in the signal pin is high, it is switch on. It is in switch on mode. If it is if the voltage is low, it is in switch off mode. Okay. So in the same program I have already written the relay pin is defined in D1. We declare it as output mode because we need to give power to the relay, and in the same program After we read the subscription from the MQTT, we print what we got, and then according to what we got, we say the relay to be in that state. Like if we got 0, I say the relay to be in state 0. State 0 is low, and state high, or state 1 is high. So now we will be connecting the node MCU to relays. रिले कनेक्शन बहुत ध्यान से करना गाइस, ठीक है? थोड़ा इधर उधर होगा तो नोड एमसीयू और रिले दोनों खराब हो जाएगा। एक बार कनेक्शन कर लो सब पैरेलली मेरे साथ, फिर प्रोग्रामिंग सेटअप कर लेना। You might have got 4 wires. जो कुछ ऐसा दिख रहा होगा दोनों एंड से, ठीक है? इसको क्या करेंगे कि split it from the ends a little bit, then take a wire, put it in 3-volt pin. It might be written 3v3 or just 3, ओके? तो उसको एकदम ध्यान से 3v3 पे ही प्लग करना, ओके? नॉट इन एनी अदर पिन। And put the other terminal in the relay where it is written V plus or V or VCC, ठीक है? Now we will connect the ground के लिए it might be written GND or G. The relay which we got accepts 2 ground, तो हम लोग 2 ग्राउंड लगाएंगे। नोड एमक्यू में देखो 2 ग्राउंड होगा कहीं पे। एंड जैसे ही VCC और 2 ग्राउंड का कनेक्शन हो जाता है रिले में, यू विल सी 1 लाइट, and then in the program we had D1, so we will plug it in D1. क्या हुआ? अच्छा, ठीक है। Now we will use this relay to control appliances. तो ये थोड़ा AC करंट है, तो वी आर नॉट गिविंग टू एवरीवन, ठीक है, अभी करके दिखा देते हैं। ये सेम सेम रिले जो पहले हम, जो यहाँ पे तुम लोग को कैमरा में दिख रहा है, ठीक है। तो इसको क्या करेंगे कि रिले में जो पिन्स होता है, ये इधर जो पिन है, ये तुम्हारा नॉर्मल जो स्विच में हम लोग स्विच में कैसे कनेक्शन करते हैं कि एक पिन लगा, स्विच में 2 पॉइंट होता है, वायर कट करके हम लोग स्विच में जोड़ देते हैं, तो वैसे ही हम लोग करेंगे रिले में, ठीक है। एक लाइव वायर जो कनेक्शन होता है, 2 वायर कनेक्शन होता है ना एसी में, लाइव और न्यूट्रल। लाइव को काटो और उसको जैसे हम लोग नॉर्मली स्विच में लगाते हैं वैसे इसमें लगा दो, ठीक है। उसके बाद क्या करेंगे कि हम लोग जो रिले कनेक्शन है सेम टू सेम, हाँ, इसके पहले एक और चीज, लाइक व्हेन तुम लोग का जब प्रोग्राम हो गया होगा पूरा सही, रन कर रहा होगा, रिले रिले कनेक्टेड होगा, तो व्हेनेवर यू आर स्विचिंग ऑफ और स्विचिंग ऑन, तो एक ट्रिप साउंड आ रहा होगा रिले से, ठीक है। अगर ट्रिप साउंड आ रहा है तो यू आर ऑन द करेक्ट पाथ, तुम्हारा प्रोग्राम अभी तक सही चल रहा है, रिले सही काम कर रहा है। अगर वो ट्रिप साउंड नहीं आ रहा है या फिर एक एक्स्ट्रा एलईडी देखो जल नहीं रहा है, रुको थोड़ा लाइट ऑफ करके दिखाते हैं। देखो ये एक एक्स्ट्रा एलईडी तुम लोग को दिखाई दे रहा है, दिस इज द ऑन मोड, एंड अगर रिले ऑफ हो रहा है तो वो लाइट भी ऑफ हो रहा है, ठीक है। दिख रहा है लाइट, रुको, देखो 2 लाइट जल रहा है, एक तो कि रिले पे पावर जा रहा है और एक रिले ऑन है, दिस इज रिले ऑफ, ओके। अब क्या करेंगे कि रिले ऑफ में मेरा बल्ब जो है वो ऑफ हो जाना चाहिए, तो ठीक है, अभी लाइट ऑफ है। आई हैव स्विच्ड ऑन द प्लग ऑफ द लाइट, ठीक है। अभी लाइट ऑफ है, तुम लोग को यहाँ कैमरा में दिख रहा है, ठीक है, यहाँ स्विच ऑफ है। जब हम स्विच ऑन करेंगे तो लाइट ऑन हो जाएगा, ठीक है, और यहाँ से स्विच ऑफ करेंगे तो, ठीक है। सबको एक बार अपना अपना प्रोग्राम रन कर लो, रिले देख लो ट्रिप हो रहा है कि नहीं, एंड आफ्टर दिस वी विल डू टुडेज लास्ट प्रोजेक्ट, कंट्रोलिंग इट विथ गूगल असिस्टेंट इफ टाइम परमिट्स। जल्दी से एक बार सबको चेक करके बताओ रिले ट्रिप कर रहा है कि नहीं। अरे थोड़ा देख लो सबको। this than that. ओके तो अगर ये होता है तो हम लोग को वो करना है. तो आई हैव अ अकाउंट पहले से. You guys click on get started and create account. Once you create your account, go to create. If this add, search for Google Assistant. Search for Google Assistant. There are 4 different types of phrases. Say a phrase with number, text ingredient, or both text and number. But we need a simple phrase. What do you want to say? I want to say turn on the light. You can write optional ways as well, like turn on light, light on, okay, and create the trigger. Than that, what we need to trigger if we say if we ask Google to turn on, we need to trigger the Adafruit switch. Search for Adafruit. Send data to Adafruit. Feed name was workshop. What data do I need to send if I am asking Google to turn on? Turn on के लिए क्या भेजना था हम लोग को? 1 भेजना था. What data to send? 1. Create action. Okay. Continue. It confirms that if you say turn on light, the data sent to workshop feed. Okay. Finish. Before this, you might need to connect your Google account to IFTTT, give the permissions. Okay. create trigger, then Adafruit. What data we need to send this time? We need to send 0, create action, and continue. Finish. Okay, so now you can see the light is on, and if I go to Adafruit dashboard, uh, 0, 1, 0, update block. If I say to my Google Assistant to turn off the light, turn off the light. The light gets turned off. ओके तो सबको इतना कर लो, रिले को खाली ट्रिप कर लो, एंड इफ यू हैव एनी डाउट देन प्लीज आस्क.